Hey everyone, in this video we're going to be talking about solving trigonometric equations. Okay, so let's go ahead and take a look and find some angle measures. So the key to solving, we're going to use our algebraic techniques like factoring and combining like terms. We're going to want to isolate our trig expression, then set our trig expression or word equal to a constant. And then we just have to think about what angles cause that constant to happen. All right, so we need to remember to not divide by a trig function. Okay, that's incredibly important. You tend to lose some answers that way. And also, when you take the square root of something, you always get two solutions, a positive and a negative. Okay. Another good thing to remember is all students take calculus to help you to remember in what quadrants each trig function is positive, and then when they're not, where they're negative. So everything is positive in that first quadrant. Sines and cosecants are positive in the second quadrant. Tangents and cotangents are positive in the third quadrant. Cosine and secants are positive in the fourth quadrant. So here's our first problem. So we want to isolate our trig terms. So we're going to add 1 to both sides first. Then we're going to divide both sides by 2. And now we've isolated our trig term. Okay, so now we just have to think, okay, what family has 1/2 as the sine value? And you should be thinking of the pi over 6 family. Then you should also be thinking, well, it's positive. So that could be pi over 6, because that's in the first quadrant where everything is positive. But it could also be 5 pi over 6, because sine is positive in the second quadrant as well. All right, for this next one, we're going to subtract 2 for both sides, giving us secant x equals -2. Remember, secant is the reciprocal of cosine, so I could also set this equal to cosine x equals -1/2. All right, so again, we're thinking, what family is that? It's the pi over 3 family, and think about when cosine is negative. That happens in the second and the third quadrants. So that's going to be x equals 2 pi over 3 and 4 pi over 3. All right, here's our first quadratic, because there's a squared. So we're going to add 1 first to both sides. We're going to divide both sides by 3. And now, to get rid of the square, we're going to square root both sides. Now, that's going to get us our tangent x by itself. We got to remember plus or minus. And the square root of 1 is 1, whereas the square root of 3 is just the square root of 3. And then normally we would rationalize that. To do that, we'd multiply by the square root of 3 over the square root of 3. And that would get us the square root of 3 over 3 plus or minus. So then you have to think, okay, what family is going to make that happen? All right, and so if you play around with your numbers a bit, you'll notice it's the pi over 6 family. Because with the pi over 6 family, here's my coordinates, right, for your basic pi over 6. And then we do y divided by x, and notice we do get that same thing that we wanted there. So because of the plus or minus, that's basically all of our pi over 6's. So pi over 6, that's when it's positive. 5 pi over 6, negative. 7 pi over 6, positive. 11 pi over 6, negative. So those are all of my solutions. Okay. The next one, notice we have signs on both sides. So let's get those together. All right, that's what we normally do with variables on both sides. So I'm going to have 2 sine x minus the square root of 2 equals 0. I'm going to add the square root of 2 to both sides. So now I've got 2 sine x equals the square root of 2. And I'm going to divide both sides by 2. So that gets me sine x equals the square root of 2 over 2. That should be very familiar. That, of course, is our pi over 4 family. Sine is positive in the first and second quadrants. So there are my answers. All right, let's take a look at the next one. So we have cotangent x, cosine squared x equals cotangent x. Let's get everything on the same side first. So we'll have cotangent cosine squared x minus cotangent x equals 0. And then I can factor out a cotangent x, and that leaves me with cosine squared x minus 1. Okay, 0. And then cosine squared x minus 1 you should recognize as one of our Pythagorean identities, right? It's actually equal to negative sine squared x. And then the zero product property says that either this or both have to equal 0 in order to multiply to get us 0. So we're going to set both of them equal to 0. So we have to think, okay, when is cotangent equal to 0? And even though it's sine squared and it's negative, well, if we divide it by negative 1 and square rooted, we're still going to get sine of x equals 0. Okay? So when is cotangent x 0? Remember, that's going to be when is our x value 0. And so that happens at pi over 2 and 3 pi over 2. For when is sine 0, that happens at 0 and at pi. All right, so now we've got this next one, 2 sine squared x minus sine x minus 1 equals 0. This is a trinomial, and normally when we were in Algebra 2, we factored trinomials. So we're going to factor this. So we have 2 sine x and sine x. That'll multiply to get us 2 sine squared x. Factors of negative 1, they're going to combine with the factors of 2 to get us negative sine x. So I'm going to put a minus 1 here, then I'll have multiply to get negative 2, and a plus 1 here. So when you add that, you'll get negative 1 sine x. So there's our factors. We're going to set each of those factors equal to 0. So I'm going to subtract 1 and divide by 2 over here to get negative 1/2. And I'm going to add 1 over here to get 1. So when does x equal, or when does sine of x equal negative 1/2? That's our pi over 6 family. And sine is negative in the third and fourth quadrants. So it'll be 7 pi over 6 and 11 pi over 6. And when is the sine value 1? It's at pi over 2. All right, here we've got another trinomial. Sorry about the bell here. But for our other trinomial, again, we're going to try to factor this. But we're going to have to change a few things, because notice there's a sine squared and then there's a cosine x. But I know there's a way we can change sine squared into cosine squared with our Pythagorean triples, right? So sine squared is actually the same as 1 minus, sorry, I said Pythagorean triples, I meant Pythagorean identities. All right, so sine squared is the same as 1 minus cosine squared. I'm going to keep everything else the same. Okay, and I'm going to distribute my 2. So I have 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Okay, I want my cosine squared to be positive, so I'm going to end up moving everything over to here. But before I do that, 2 minus 3 is going to be negative 1. Of course, when I move it over, it'll be positive. So when we move everything over, we'll have a positive 2 cosine squared x. We'll have a negative 3 cosine x. And we'll have a positive 1. Okay? So now let's factor. Okay, so I'm going to have 2 cosine x and cosine x. That's going to multiply to get me 2 cosine squared x. I want to get a positive 1 but a negative 3, so it's going to be both minus 1s there, and that will combine accordingly. So now I'm going to set both of those factors equal to 0. And that's going to be, I'm going to add 1 and divide by 2. I get cosine x equals 1/2. And then I'm going, well, cosine x equals 0 is already good to go. Oops, I added 1. No, I didn't. I dropped off the 1 completely. Sorry, this is a minus 1 0. And then I'm going to add 1. So cosine of x equals 1/2. That happens for the pi over 3 family. And when is it positive? It's going to be positive pi over 3 and 5 pi over 3 in the first and fourth quadrants. And then when is cosine of x equal to 1? That's actually at 0. All right, last problem here. So again, we've got a trinomial. Let's factor it. So I've got cosine x and cosine x. I've got a 2 and I've got a 1. And then it's going to be a positive 2 and a negative 1 to get me that positive 1 cosine x. So now we're going to set cosine x plus 2 equal to 0 and cosine of x minus 1 equals 0. All right, we're going to subtract 2 here, so we get cosine of x equals negative 2. And we're going to add 1, and we get cosine of x equals 1. Now, looking over at this one, cosine of x equals negative 2. That never happens, okay? It's not a thing, all right? So we know that this one is no solution for this part. This is not a solution. And then when is cosine of x equal to 1? At x equals 0. And that's solving trigonometric equations.